An important skill in organic chemistry relates to acid-base chemistry. We need to be able to compare protons to see which will be most reactive. This has to do with proton acidity. We can determine this by looking at the conjugate base and how well it stabilizes the negative charge. There are 4 factors ranked in order of importance, and these are element effects, resonance, inductive effects, and hybridization. The first factor is element effects. Here we have 2 similar structures, one with nitrogen and one with oxygen. First, let's draw the conjugate base for each acid. So by removing the proton, we will have a negative charge on the heteroatom. So the first structure, we have that charge on the nitrogen, and the second, we have it on the oxygen. So with element effects, we need to be thinking about size and electronegativity. So nitrogen and oxygen are both on the same row of the periodic table, so they have fairly similar size, but since oxygen is further to the right, it has a higher electronegativity. This makes it better able to stabilize the negative charge. So this conjugate base is more stable, making this proton more acidic. The second factor is resonance. So again, let's go ahead and draw that conjugate base. So by removing that proton, again, we'll have that negative charge on both of the oxygens here. But the difference with the structure on the left is that we have a resonance structure. So we can move the negative charge to a bond, and then we get a resonance structure here. And this makes it more stable because you're able to distribute that negative charge throughout the molecule. So in this case, this allows for a more stable negative charge, making this proton more acidic. The third factor relates to inductive effects. So again, we have 3 similar structures, and let's draw those conjugate bases. So first we have the alkyl groups with that negative charge still on that oxygen. Similar structure here, the negative charge also on the oxygen. And then our third structure has 3 chlorine groups adjacent to our carboxylic acid. When we remove that proton, the negative charge will be on that oxygen. So when we talk about inductive effects, let's think about how the electron density throughout the molecule is distributed. So are there any groups that will donate electron density or withdraw that electron density? So in this case, with the alkyl groups, these are electron donating. And so because these are all partial positive, they want to donate their electron density, but this makes it less stable of a negative charge because now it has more negative charge toward those extra electrons. So that's less stable. So this proton will be less acidic, making it more basic. And then we have our intermediate here where we don't have any electron donating or electron withdrawing groups. But then on the right-hand side, these chlorines all have a partial negative. And these are electron withdrawing. And that means they're drawing that negative charge from the oxygen over here with those extra electrons and the negative charge. And so they're distributing that electron density throughout the structure, and this makes it more stable. And so, again, this proton will be more acidic. So that's an example of inductive effects. Our final factor is hybridization. So we need to take a look at what hybrid orbitals are present in our structures. So let's go ahead and draw the conjugate bases one last time by removing those protons. And so what hybrid orbitals are present in these structures? So here we have a double bond, which means we have an sp2 hybrid orbital. And here's a triple bond that is sp. Now in this case, we need to think about the size of the hybrid orbitals. So an sp orbital is going to be smaller in size, so it's holding that electron density closer to the nucleus, which is positive. So this is more stable, making this proton more acidic. So then we can think about it as sp3 orbitals being the least stable, because those are the largest. So sp is the most stable and will provide a more acidic proton. So there we have it. Those are some examples for each of our factors relating to charge stability and proton acidity. And let's remember that these factors are ranked in order of importance. So factor 1 is going to be the most important. So look at elemental effects first, then look for resonance, then look for inductive effects, and then look for hybridization. So those will affect the acid-base chemistry of your compound. So comment down below if you have any other questions or if you have suggestions for other practice problems, and good luck doing your chemistry.